Hey there, welcome to today's tutorial where we are going to look at compound and continued proportions. Before we start on it, I want us to first of all discuss the principles or the concept behind compound proportion. Okay, concept number one about compound proportions is that if A, B, C, and D are terms such that A over B, the ratio of the fraction A over B is equals C over D, which is equal to a certain constant K1. For example, if we have terms like 3, 6, 3, 6, 17, and 34 to be our terms A, B, C, and D respectively, then we say that 3 over 6 is equals to 17 over 34. If you simplify completely, you're going to get K1 as half. That is principle number one. It is also true to say that if these ratios are equal, then these terms are in proportions. It is also true to say that A over C is equals B over D is equal to a certain constant 2. If we use our examples, that is 3, 6, 17, and 34, to represent our A, B, C, and D, then what we mean that this is A, 3 over C, this is A, B, C, so it is 3 over 34 over 17 is equals B, which is 6 over 34, I beg your pardon, yeah, of course, 6 over 34 is equals to K2. If you do the simplification, because this one is completely simplified, if you simplify this one by 2 and by 2, you are going to get 3 over 17. So, if A, B, C, and D are terms, and A over B is equal to C over D is equals to a constant, then it means that A over C is equals to B over D, which is equal to a different constant. Okay, on continued proportions, we are going to look at, maybe we can also say that we can have some terms. If we consider terms like, maybe let's consider terms such as, maybe you can have 2, 4, 8, and 16. And we let 2 be A, 4 be B, 8 be C, and 16 be D. So, if that is the case, then it is true to say that, okay, so if we have these 2, 4, maybe I can write it over here, 8 and 16 are terms, and they are represented by A, B, C, and D, then we say that they are in continued proportion if A over B, if we take the successive ratios, AB equals BC equals CD equals constant. there is a slight difference if we compare with compound proportion, because we didn't take the successive ratios. We just took A over B equals C over D equals a certain constant. Then we say those terms are in proportion. But when we are talking about continued proportion, we say that A, B, C, and D are in continued proportion if their successive ratios are equal to a common constant. All right? If you look at the compound proportion, the successive ratios are not the same. 3 over 6 is not equal to 6 over 17 and is not equal to 17 over 34 because we have not taken successive ratio. But for the continued proportion, we have taken the successive ratios. For example, 2 over 4 is equals 4 over 8 is equals 8 over 16 is equals a certain constant. And in this case, it's half. All right? So, A and T are referred to as extremes because extremes, they are on extreme side. The beginning side and the towards the end is D, so they're extremes. B and C are in the middle. These are the terms that are in the middle. They are the ones that we are calling the means. And therefore, if A and B is equals to constant K, and B over C is also equal to constant K, also C over D is equals to constant K, and then we consider these ratios, then we have A over B is equals B over C, which is the same as if I do the cross multiplication, will be AC is equals B squared. All right. Same case, if we take these other ratios, we shall have B over C is equals C over D. And remember, they are equal to a constant. We shall have C squared is equals to BD. So that is why we are saying they are mean of the terms. And you can be asked to find any of the terms if the terms are said to be in proportion. Now, from that point, we have noticed that continued proportion and compound proportion are the same. Why am I saying are the same? If A over B is equals to B over C is equals to C over D is equals to a constant, then it is also true to say that A over B is equal to C over D, which is equals to a constant. And this is the same as the compound proportion. So it is true that A over B is equals to C over D is equals to K. A over B is equals to C over D is equals to K. All right? So it is true. Another thing that we need to note is that if we take examples, because in this case we have A as 2, this is our A, B, C, and D to avoid confusion. Our A in this case is 2, B is 4, is equals C is 8, is equals D, which is 16, is equals to half. Okay? And this is what we are calling constant 1. It is also true, just as we said that A over C is equals to B over D. If we look at this one, that just as we said A over C is equals to B over D, is equals to another constant that is not the same as the first constant, then it is also true to say that 2 over 8 is equals to 4 over 16. If we do the simplification, we shall get 1 over 4, which is another constant. So this means that A, because 2 is our A, over 8, which is C, is equals 4, which is B, over 16, which is D, which is D, and is equivalent to another constant, K, which is very well agreeing with what is the compound proportion. So these concepts or these principles are the ones that we are going to use, or that you need only to master when it comes to compound and continued proportions, I beg your pardon, in all the problems that you encounter concerning compound proportions. Now, in case you may be asking yourself, how can I differentiate between compound proportion and continued proportion? The difference between the two, because we have seen they have two commonality, but their difference is that a continued proportion forms a geometric sequence, or it is a geometric progression. It's a GP. When we talk of GP, if you remember, the principles guiding geometric progression, GP, are they two? Yeah. So one of the principles is that they have a common ratio. Common ratio, that is when you divide 4 by 2, you get 2. When you divide 8 by 4, you get 2. So the common ratio, which we referred as to in our previous tutorials as R, is 2. So if terms form a geometric progression or sequence, then that one is definitely a continued proportion. That is the only difference. So the other one, the compound proportion, that is not a geometric progression, but the other one is a geometric progression. So let us look at the example, how we can apply these two concepts in our problems. KLB exercise 14.1. So 14.1, number 5. So number 5. And it is saying that if P, Q, R, and S are in continued proportion, show that 2P plus R over 2Q plus S is equals P minus 3R over Q minus 3S. So we are supposed to show that they are equal. How do we go about this? We have been told that it is in continued proportion, but it doesn't matter whether it is in continued proportion or compound proportion. The idea here is that these P, Q, R, and S are in proportion. If they are in proportion, then there are only two guiding principles. And principle number 1 is that A over B is equals C over D, which is equal to a constant 1, and A over C is equals to B over D, which is equals to constant 2. Maybe to remember about continued proportion, also of important, is that if A, B, C, and D are in continued proportion, it is true that now A over B is equals to B over C is equals to a constant K1, and that B squared is equals AC. So we have two guiding principles when it comes to problems that are involving proportion. Okay. Now, having said that, so our argument here is we make these unknowns to be uniform. So I want to put either P to become Q and R to become S, or Q to become P and S to become R, using only these three guiding principles. So looking at the problem we have at hand, principle number 3 is not going to be used in this problem, and therefore we put it aside. And now try to see how we can use principle number 1 and 2 to help us tackle this problem. So we have P, Q, R, and S, and we have been told that they are in continuous proportion. And I have told you what we want to do over here. So if we take principle number 1, is it going to help? Let's try to check whether it is going to help us. So if P is our A, Q is our B, R is our C, and S is our D. So what do we do now? AB PQ, that is PQ, is equals to CD, which is now RS, which is equals to a constant, a certain constant. Now, if both are equal to K, then it means that P over Q is equals to K, and R over S is equals to K too. Now, if we express P in terms of Q and K, then P is equals QK. When we do the same, we express R in terms of S and K, then we have R is equals SK. Now, P, if we substitute P with QK, then they will correspond with 2Q. If we take R it will be equal to SK, then this R, which is now SK, will correspond with this K, with this S. If we do the same, P, QK, Q, 3R, then it shall be SK, 3S. So this principle is the one that is going to help us solve this problem, or help us to prove that 2P plus R over 2Q plus S is equals to P minus 3RQ minus 3S. Now, having done that, let's proceed with the first step. And the first step, or the first method mark, you acquire it by substituting. When you make the correct substitution, so we have, instead of P now, where we have P, we write QK. Where we have R, we substitute with SK. Okay? Yeah, I know you got it. So 2, instead of P, we write QK. Plus, instead of R, we write SK. All over 2Q plus S is equivalent to P, instead of P, it's QK. Minus 3, instead of R, we have SK. All over Q minus 3S. So far, so good. So we have now 2QK plus SK all over 2Q plus S is equivalent to QK minus 3SK all over Q minus 3S. Now, we factor out a common factor, and in this case, common factor here is K. So we factor out K, we are left with 2Q plus S all over 2Q plus S is equivalent to K. Here again is common factor, we factor it out, we are left with Q minus 3S over Q minus 3S. Now, if you look at this parts very keenly, we have like terms, and then they will cancel. Then we are left with k is equals, this is also common, we cancel, we are left with k. So having k is equals k, this proves that so k is equals to k. So it means that this side is equals to k and this other side is equals to k, and therefore we say both are equal to k, and therefore they are equal. As simple as that, guys. I hope you have enjoyed this tutorial. Don't forget to do the obvious. If you want to join this family where we make mathematics and biology a bit subject, don't forget to subscribe, and turning on your notification bell is doing a favor to me. Share, and until next time, it's a bye.